Hey there Bolters, welcome back to another tutorial. Now today we're going to be talking about something that can quietly make or break your entire project, and that is your bandwidth. Here's the thing, when you're building with Bolt, things can feel very snappy and quick. However, when you consider real users who may be on a mobile connection or geographically located far away from your server, then that's when bandwidth becomes a very important consideration. This is where developers get a little caught off guard. They may ship something that works, however, they've never asked themselves the question, how much data am I actually sending over to the user? For example, a single unoptimized image can often be larger than your entire TypeScript bundle. A profile avatar, which should be 20 kilobytes, could be something like 2 megabytes if you haven't considered it properly. Now multiply this by all the assets on your page and then all your users, and you may quickly exceed your bandwidth limitations. It means the load times will drive users away from your site before they've even ever seen your content. In this video, I'm going to show you exactly how to spot these problems using your browser's network inspector. And then we're going to learn some practical tips as to how to optimize your app for scale so that no matter what device your users are on or where in the world they're located, your app will be optimized for them. Let's dive in. Here's a demo project that I've built that we're going to use as an example. Now, the idea of this is you can turn any prompt into a golden hour portrait photography session. Let's look in the version history, and we can see it's only used about 12 prompts. Let's see how it works. So here we go. It's created a photograph of a dog with a monocle, and it's added it to our recent generations down the bottom. We can view our past generations just like this. Now let's publish our app. So here's our project on a live URL. We right-click, go down to Inspect, and this is where we can see Elements, Console, Sources, and we're going to choose Network. Let's disable the cache and refresh the page. Now we can see all of the assets that have been loaded with this page. It took 4.2 seconds to load, and it's used 45.3 megabytes of bandwidth to load this page. We can filter the assets by size, and here we can see all of our largest assets, noticing that each image is between 2.5 and 1.5 megabytes each. This was the default size that the OpenAI image generator sent these images back to us at. Now, to put this into perspective, if we had a full screen hero image that was the background of our hero section, and we optimize this, often it can be somewhere between 200 kilobytes and 500 kilobytes. So between a tenth or a quarter of some of the images we're seeing here. Unless we're downloading these images to print at a large scale, we don't need them to be this large. Now, there are two main reasons why we like to reduce the file size of some of these large images. Now, the first one is for the user. It's going to use less internet connection and the page is going to load faster. The second one is for the benefit of you, the developer, and it means you'll be using less bandwidth to serve these images to your users. Jumping into Bolt, let's look at our settings. And underneath Cloud is where you'll see our monthly limits that are included in our plan. It's not very expensive, but as soon as we start exceeding this 30 gigabytes of hosted bandwidth, then we need to start paying extra. We can always change the spending limit up here. Depending on the amount of users that you have and the type of application it is, hopefully you can optimize it so you don't need to use this. Another consideration is how large the images actually are. Notice that these are very small thumbnails until we click on them and then they load. Even then, they're nowhere near the full size of the screen and they're quite small. It means that we can serve a much smaller file size from the server to the user. Perhaps if the user wants to download the image in full quality, we can allow that as well, but most of the time they're probably just previewing them here within the website. Notice while inside the Bolt preview, we can also inspect the page here. Right-click, inspect. We click on network, refresh the page. Now there's some more items in here, but ultimately we can still see the assets too. Now comes the fun part. Let's prompt the agent so we can optimize the file size of these images and use less bandwidth. Notice that the file size of the images in the recent generation sections are very large. When saving an image to the database, please also save it a much smaller optimized image so that I can reference this in the recent generation section. We'll plan it out and send it. Asking a question like this in plan mode is effectively a one-on-one with an infinitely patient, very knowledgeable tutor. Here's what it's saying. Generate compressed thumbnails in the Edge function. After uploading the full-size image, create a small WebP thumbnail from the same base64 image data. Use a lightweight image processing approach to downsize it. Save it as a much smaller file size. Convert this downsized image to a WebP format, which is an even smaller file size. Then save this thumbnail image to the Bolt database under a different path in the same bucket. It's also updating the database to include this new URL and updating the front end as well. Let's answer the clarifying questions. It's asking us if we want to retroactively generate thumbnails for the existing generations. Why not? Let's see how well this works. We've answered those, turn it off plan mode, and we'll send it off. So the agent's finished working, and let's look through what it's done. It's updated the Edge function, which is the API call to OpenAI to generate the image, to create these WebP thumbnails and save the thumbnail URLs. We've also generated thumbnails for the existing 21 images. So let's publish the app and test it out. So here we are on the old page. We can see all of these images are over 2 megabytes. Let's refresh. We've reloaded the page, and now we can see each of these images now use less than 100 kilobytes each. The page loaded in less than half a second, and the total bandwidth was 2.2 megabytes instead of 40 something like it was before. This was one optimization that we did, and it reduced the bandwidth by about 20 times. Now, this was our first attempt at optimizing. If you wanted to take it even further, I'm sure you could discuss with the agent and get our images even smaller than this without compromising quality too much. And there we go. It was as easy as that. In this video, you've learned all about bandwidth considerations that you should keep in your mind, especially when using images within your app. We learned how to use the browser's network inspector so you can determine exactly how much bandwidth each page load uses. And then we learned how to prompt the agent so we can be a lot more efficient with the bandwidth consumption, making us more confident in how we're scaling our app to a wider audience. I hope you've enjoyed this video. As always, if there's any content you'd like to learn about, please add it in the comments below, and keep on bolting.